Okay, now we will be discussing the Module 9 of SIEE course, so which is the FHRP concepts, right? So this module only contains two topics, so FHRP, then SHSRP, FHRP. Hi, introduction. So what we are going to do in this module, module title is FHRP concepts. So we will need to explain how FHRP provide default gateway services in a redundant network. And also we have here two topics. The first, the redundancy protocols of or FHRP. So we need to explain the purpose and operation of this, and then HSRP. So explain how HRP operates. So this module is all about a solution for whenever a default gateway fails. Okay. First hop. Okay, so default gateway limitations. So if a router interface that serves as a default gateway fails, the hosts reconfigured with that default gateway are isolated from outside networks. Okay. So a mechanism is needed to provide alternate default gateways in switch networks where two or more routers are connected to the same VLANs. So the mechanism is provided by the FHRP. Okay. Let's go to this figure. Okay, so in this figure, R1 is responsible for routing packets from PC1. Okay, we have here the R1. Then it said that this is responsible for routing the messages for from the PC1. So if R1 becomes unavailable or failed, the routing protocols can dynamically converge. So R2 now routes packets from outside networks that would run through R1. Okay, so however, traffic from the inside network associated with R1, including traffic from workstation, servers, and printers configured with R1 as their default gateway, are still sent to R1 in job. Okay, so the R2 here is responsible for routing messages from the outside networks. So it's example from here. So from here to the PC. So the R1 fails, but the packets from the PC1 or the inside network, so it still goes to R1, I think. Okay, and then since the R1 is failed or what do you call this, unavailable, so it just drops the packets. But the PC1 can receive traffics from outside networks through R2. Okay. Okay, so end devices are typically configured with a single IPv4 address for a default gateway. So this address does not change when the network topology changes. Okay. So if the default gateway cannot be reached, the local device is unable to send packets of the local network segment, so effectively disconnecting it from other networks. So even if a redundant router exists that will serve as default gateway for the segment, there is no dynamic method by which this device can determine the address of a new default gateway. So like this one. Okay. So one way. So okay. So router redundancy. So one way to prevent a single point of failure at the default gateway is to implement a virtual router. So to implement this type of router redundancy, so multiple routers are configured to work together to present the illusion of a single router to the host of the LAN shown in the figure. So sharing an IP address, MAC address terminal act as a single virtual router. Okay, so in this figure we have here the virtual router. So the virtual router acts as the default gateway for all these species. So I have here the forwarding router. So these two routers here shares the IP address and the MAC address as a virtual router. So I think the virtual router is not the physically exist. It's just a virtual. Okay. So the virtual router decides whether these routers are in forwarding state or just a standby waiting for uh, to be waiting to be a forwarding router if ever that this router fails. Okay. Let's see. Okay. So protocol is used to identify normal routers as the device that are responsible for processing frames that are sent to the MAC address or IP address of a single virtual router. So whose device sends traffic to the address of the virtual router. The physical router that forwards this traffic is transparent to the devices. The transition from one forwarding router to another is transparent to the end devices. So all of this, all of the traffic sent by this host are sent to the virtual router. So the virtual router sends us serves. So the virtual router serves as a router, which is a single router for multiple routers. Okay, so the multiple routers have a single IP address and MAC address as a virtual router. Then it also said that the transition is transparent. So whenever this router fails, so the forwarding router will transition to this one, and then the host will not notify that this router fails, or the transition between these routers are transparent to the host. We have these steps for router failover. So when the active router fails, the redundancy protocol transitions from the standby router to the new active router role. So as shown in the figure, these are the steps that takes place when the active router fails. I will have here 3 steps. So the first one is the standby router stops sending hello messages from the forwarding router. Second one is standby router. So this one stops sending the hello message. Okay. Then the router assumes the role of forwarding router. And then because the new forwarding router assumes both the IPv4 and MAC address of the virtual router, the host devices see no disruption in the service. Okay. So the host devices see no disruption in the service. Okay, the transition is transparent. So as you can see, if this router fails, so the virtual router decides that this standby router will be the new forwarding router. Easy as that. So the ability of network to dynamically recover from the failure of a device acting as a default gateway is known as first hop redundancy, FHR. So the protocol is FHRP. FHRP options. This is the next step, the standby router protocol. So there are several options for FHRP. So FHRP is the protocol as a whole. So FHRP option is so FHRP since the production environment largely depends on the equipment and needs of the network. Okay, so these options here are based on the equipments and needs of the network. So we use the functionality or services of FHRP. So it depends on the network. So the first one is we have the HSRP or Hot Standby Router Protocol. So it's Cisco proprietary FHRP that is designed to allow for transparent failover of a first hop IPv4 address. So I think the last example are HSRP. So FHRP for IPv6, so the same functionality, so but in IPv6 environment. So we also have the VRRP v2, the virtual router, that is protocol version 2. So it's not a Cisco proprietary, so it's vendor, what do you call this, vendor free, no, whatever. So this is not non-proprietary election protocol that dynamically assigns responsibility for one or more virtual. Okay, and this VRP configuration, one router is selected as the virtual router master or the forwarding router with the other routers acting as backup or standby. I think the only difference is it's a non-proprietary. The VRP v3, so it's I think the same with this one, but it supports the IPv4, IPv6 address. Okay, the multi-vendor. So it supports multi-vendor. So it runs regardless of any vendor or different vendors. Okay. We also have the Gateway Load Balancing Protocol or GLBP. So it protects. So it is an FHRP that protects data traffic from a failed router or circuit. So it also like these two protocols here. So it also allows load balancing between a group of redundant routers. It's load balancing. Improves the distribution of workloads. What? Process distributing network traffic. Okay. Dividing the traffic. Okay. GLBP. So I think just runs on IPv6 environment. So it's a GLBP. The ICMP router discovery protocol. So it's specified in RFC 1256. RIDP is a legacy FHRP. Okay. It's an old solution for router redundancy. So it allows IPv4 hosts to locate routers that provide IPv4 connectivity to other. Okay. The 5 questions. What type of device routes traffic distinct to network segments beyond the source network segment for which is sending out the intent? So here the default gateway. So it routes traffic destined to the network segments. Okay. The segments of, for example, the interface of the router. The segments of this. So we have the default gateway. So what device presents the illusion of a single router to host on a LAN segment but actually represents a set of routers working together? So we have the virtual router. So a multiple router acts as a single router. So what device is part of a virtual router group assigned the role of alternate default gateway? So we have the standby router. So it's just a backup router if ever the forwarding router fails. So what device is a part of virtual router assigned the role of default gateway? The forwarding router. So which FHRP or Cisco priority? Choose 2. We have here the answer. So the second topic before, I think we have here the first packet tracer. The only one packet tracer for module 9. On module 8, we don't have packet tracers, but we have the lab. Okay, here we go again for the teaching course. Just a review for us. So FHRP overview. It's the same. So there's multiple routers. So there's a multiple router acting as a single router, so known as the virtual router. So if ever the forwarding router fails, there's standby devices or standby routers to serve as a forwarding routers. So HSRP priority and preemption. So priority. Oh, so we also have the election process. So we're in which router will be the forwarding router or the standby router. So by default, the router with the numerically highest IPv4 address is selected as the router. Okay. So however, it is always better to control how your network will operate under normal conditions rather than leaving it to chance. So we have here the HSRP priority and preemption. So the router with the highest HRP priority will become the active router. So by default, the HSRP priority is 100. So if the priorities are equal, the router will with the numerically highest IPv4 address is selected as the active router. I also have the command for active router to be elected as active router. We have the standby priority. So HSRP preemption. So by default, after a router becomes the active router, it will remain the active router, even if the another router comes online with the higher HSRP priority. Okay. So we also have the command for HSRP preemption, so standby preemption. So preemption is the ability of an HSRP router to trigger the election process. So okay, whenever the router comes online with a higher HSRP priority, so it will assume the role of the active router. So we need to first to configure the preemption command or configuration. So if we don't configure this, so even a router comes online with higher higher HSRP priority, so it will not be elected as a forwarding router. I think as you can see here, we have here two routers. So this one has the higher priority of 150, then the standby router priority of 100. I think if this fails, it will be as elected as the forwarding router. But without the preemption, so I think this, whenever this, for example, we have the priority of this as 200. So it will not assume that this will be the forwarding router. So it should be, we should configure this router. I think this router as preemption, standby preemption. So for it automatically elect whenever this router has the higher priority. Okay. So in this example, we have here the R1 and R2. So this the R1 have the high priority than the R2. So this one fails, and then the R2 assumes that so the R2 becomes the forwarding router. So without the preemption, HSRP preemption, so if this R1 gets back with a higher priority, so this will not be a forwarding router. So but with the preemption enabled, so the router will be forced to have an election, and then the forwarding router will be back to R1. So HSRP states and timers. A router can either be the active HSRP routers for forwarding traffic for the segment, or it can be passive, so ready to assume the active role if the active router fails. So when an interface is configured with the HSRP or it's first activated with an existing HSRP configuration, the router sends and receives HRP data. So the forwarding router sends and receives. Forwarding router sends. This the one the standby router receives HSRP. Hello, begin the process of determining which state it will in the HSRP. So I think every 3 seconds, so it sends hello packets. So if here defined HSRP state, then the description we have the initial. So the state is entered through a configuration change or when an interface first becomes available. Then they learn the router is not turning the virtual IP address enough. Just seeing hello message from the active router. So in this state, the router waits to hear from the active router. So we have the learn state. In the listen state, the router knows the virtual IP address, but the router is neither the active router nor the standby router. It listens for hello message from the router. So in this listen state, we now have the IP address and the MAC address, but there's no election happening. So speak, the router sends periodic hello messages and actively participates in the election of the active or standby router. Now the standby router is candidate to become the next active. Okay, on this speak we have the forwarding router. So it is now participating. On the standby is a candidate to become the next active router and sends periodic hello messages. For questions, what is the default HSRP priority? We have the 100. So if a router with the highest HSRP priority joins the network, will take over the active router role from an existing active role, which is the lower. So it depends. So if the router is preemption enabled, so it will be dynamically elected as the active router. So if it has the higher priority, but if it's not, we have the false. So even if an active router becomes online with the higher priority than the existing active router or forwarding router, so it will not be elected as forwarding router. So during which HSRP status, interface begins sending hello messages. We have the speak, okay, so which is characters. Speak or speak. So which is a characteristic of the HSRP learn state. It's not determined. So we have the router knows the virtual. I think this is the listen, the speak, this is also speak, learn. No, it's listen. I know. Hi. Module practice and quiz. And this module learn the first half redundancy protocols. So we have the virtual router acts as a single router for multiple routers. So if ever the router fails or a forwarding router fails, so there are standby routers to be served as to be the next active router. So we have here the FHRP, first half redundancy, we call that. So it's a process of, no, it's not a process. Just a prevention or an act of preventing failure for routing. We also have the 3 steps. Stop seeing hello messages. So the standby router assumes the role of forwarding router, and then the standby router uses the IP address and MAC address of virtual router. So the host devices see no disruption in service. It's magic. also have different FHRP options. So based on the equipments and needs of the network. So we have the HRP, we have the IPv6 for the IPv6 environment. So also tackle the HSRP. So we tackle how the routers elect. So also talk about the preemption process, the election process. So it also depends on higher priority of routers. So module quiz. Okay. 15 questions. What is the purpose of HSRP? Network connection for the water failures. For non-proprietary, so we have the VRP. So a network administrator is analyzing FHRP, sports IPv4 and IPv6. So what is a potential disadvantage when implementing HSRP as configured? So it does not provide advanced. Kaya network engineer is configuring a LAN. Which protocol should the engineer implement? So with the GLBP. So because the GLBP have the load sharing or load balancing. So I think this is the better use for redundant first hop. Okay. So when the first hop redundancy protocols are used, which two terms will be shared with the virtual source? Okay, the virtual router. So we share the IP address and the MAC address. So in FHRP terminology, what represents the buttons? Okay, the virtual router. So network engineer is configuring a LAN with redundant first hop. What? So GLBP. So the question repeated. So what is the purpose of okay? So the user needs to add redundancy to the routers. With the HRP, VRP, and GLBP. Spanning tree protocol IPv6, right? Which protocol? Redundancy at layer 3. Layer 3, so choose 2. The network is always been offered Cisco proprietary. So FHRP protocols that is Cisco proprietary have the HSRP and GLBP. So these are none, so it's multi-vendor blah blah. So which statement describes a characteristics of GLBP? Load balancing. Load balancing provides multiple virtual IP addresses. What? Don't know. So which non-proprietary IPv4 LANs? Okay, we have DVR non-proprietary, so it does not leads to some people cell. No. Networking. Server load balancing. Okay. So that acronym exists. So network administrator is nice and different. First off, load balancing check. Provide support for IPv6. Provides one. What? Automatic routing. automatic rerouting, if any. But this is answer is too broad, so it can be uh, it is also applicable for other FHRP options. Also the FHRP path tracer. So I think we will be doing that later on. And the next topic will be the land security concepts. Okay, modules. So this 4 modules here, we already have the YouTube video for that, because we first take this course, so the SRW bridging course. So this course contains these 4 modules, but we will be having a new video for that. So we will be tying up the loose ends. So some of the parts in this module I did not understand with that. Some of that. So that's it.